So I kind of skipped the. There's a thing in the book that talks about strategy. You could look in the book if you want to read it. But I didn't want you guys to have to write all of it down. It was just a page of stuff. And it's like, if you see this, then do this, then do this. But what we want to do is we want to try to graph this function as a transformation of the parent function. Okay? So when we go to do that, right now we're working with this. Y equals capital A sine of B times x, where A equals negative 1/2 and B equals pi. So let's unpack A. So A, because it's negative, we'll flip it. And because A is trapped, because the absolute value of A is less than 1, it compresses it vertically. Also, the range would be from negative 1/2 to positive 1/2. And you'll include it too, so we should probably put the equals to. So when I click on this graph, so right now I have in red the graph of sine of x. Okay, so let's label that. So this is and so this is 1 and this is negative 1. And the period is 2 pi. But now for our new graph, y equals negative 1/2 sine of this, I'm going to have, it's going to go from positive 1/2 to a negative 1/2. Okay? Now B has an impact on the period. So remember that for sine, it's from negative 1, the range is from negative 1 to 1, and that the period P is equal to 2 pi. So from here to here, this point right here is 2 pi, comma 0. Okay? That's sine. But because I have B equals pi, I know for my second function, the period P is going to equal 2 pi divided by B, or 2 pi divided by pi. The pi's will cancel. Pi divided by pi is 1. 1 times 2 is just 2. So my period of my new function is 2. Okay? And I'm going to zoom in because we're going to try to graph this bad boy. So my first point is going to start here. But the period is only 2. So I have to complete that whole cycle by this next dot, which is 2. And then the cycle repeats again here. But I can't go over 1/2 or negative 1/2. So I'm going to kind of sketch out a little thing here. So it has to kind of fit in this window, and I'll fine-tune this bad boy here. That's kind of like my guide, okay? It has to fit in that window, and then I'll delete it, and you'll see what I'm talking about. But this is what you got to think in your head. Now, normally I would draw like a dotted line and all that stuff, but so it's got to go one period. That means it's got to go up, down, and back. So from here to here, I'm going to go up and then I'm going to go down here and back. Then I'm going to go up, then down. Whoops. This is really hard to do with this tablet. Up, then down and back. Then I got to do it again. Up, then down and back. And then we do the same thing in the other direction. We're going to go down and up, down and up. And that's it. I'm just going to, normally I just do like from pi to 2 pi. Well, we'll do one more. We'll go to pi to 2 pi. Go down and up. Okay? And so when I remove my little boundary, normally I sketch that or just draw it lightly with my pencil with like a dotted line. But when I remove this, that's what my graph will look like. Okay? Yes? Oh, you're right. You know what? I forgot it was negative. We're supposed to flip it. So we got to do it backwards. My bad. So let's undo all this stuff. Thank you. I forgot all about it. The student raised her hand and said, "Don't you flip it because it's negative?" That is absolutely correct. So instead of going up and down, we got to go down first. So it would go down and up. Down and up. And the same thing here. We're going to go up, down, up, down, up, down. And let me finish this one off here. Okay, so that's kind of what it would look like. So now if I remove that boundary, I just kind of sketch that in there. That's kind of what it will look like. Okay, so but that's if you sketch it by hand, right? And how can I double check it? Well, I'm just going to plug it into Desmos. So I'm going to open another tab, which I shouldn't have done that. Let me do this way. And I'm going to do sine of x first. That's what we had. And then I'm going to say negative 1 divided by 2 sine of. Now on Desmos, if I type in pi, it automatically switches to pi. And then I put x. Oops, not xo. Just x. And as you can see, that's exactly what we have. Okay? I'm going to zoom in so we can get a little bit better look at that. We'll do like negative 2 to 2. And so if you look at the 2, well, I'm just going to take a picture of this and we'll see. Obviously, the graphing calculator does a much better job than Mr. Adams drawing it by hand. Let me see if I can get in there. Let me do it one more time. And we'll put that in here. Actually, I should probably put it, let me put it in here somewhere.